So today we will be solving this problem from homework set 5. The question is, a child sits on a fiberglass swan fastened 8.5 meters from the center of a merry-go-round platform that is rotating once every 9 seconds. What is the child's speed while sitting on the swan? What is the kid's acceleration while sitting on the swan? And what is the child's acceleration if he moves to the rubber platypus fastened 6.6 meters from the center? So to start off, I'm going to draw a picture of what this will look like. And so we have a circle for the merry-go-round, and to begin, R is equal to 8.5 meters because that is how far from the center the kid is sitting. So for the first question, we need to find the child's speed while sitting on the swan. And we know that velocity is equal to the change in distance over the change in time. So for the distance, it'll be the distance they travel around the circle in the mentioned amount of time. So to find the distance traveled, we'll need to find the circumference of the merry-go-round platform. And circumference is equal to 2 pi r. So change in distance, which we have as a circumference, is 2 pi times 8.5 meters. And this gives us 53.41 meters. And so next, so that's the distance traveled. To get velocity, it's change in distance over change in time, which is going to be that 53.41 meters divided by the time, which is 9 seconds, because as it travels one complete rotation, it takes 9 seconds. So we divide those and we get 5.934 meters per second. That's the answer to the first question. So next, we need to find the kid's acceleration while sitting on the swan. And so, because the kid is traveling in a circle, the acceleration is going to be towards the center, which is centripetal acceleration. So we know that centripetal acceleration is equal to v squared over r. And we found the speed in the previous question, so we know that it's 5.34 squared over r, which is the radius of the circle, which is 8.5. And that gives us 4.143 meters per second squared. And that is the answer to the second question. And so for the third question, we would find the acceleration if he moves 6.6 meters from the center. So we draw a new picture, and R is now going to be equal to 6.6 meters. And we are basically just going to repeat the process we did for the first two questions. So first we need to find the distance traveled in one rotation, which we know is the circumference, which is 2 pi r equal to 2 pi 6.6. And that gives us 41.67 meters. And so now we need to find the velocity so that we can find the acceleration, because the centrifugal acceleration is equal to v squared over r. So to find velocity, it's the change in distance over the change in time. And we know c, or the circumference, equal to the change in distance when he makes one rotation. So this will be 41.67 meters over the time, which is still going to be 9 seconds, because it takes 9 seconds to complete one rotation. And this is the same even though the child is sitting at a closer distance from the center. So divided by 9 seconds, and that gives us 4. One second. 4.61 meters per second. And so now to find the centripetal acceleration, which is going to be the child's acceleration as he's sitting 6.6 meters from the center, we do v squared over r, and v is 4.61 meters per second squared over r, which is the radius, which is 6.6. And then we plug that into the calculator, and we get that the centripetal acceleration is 3.217 meters per second squared. And so when we did this, we know that the child is not accelerating when the only okay, sorry about that. The acceleration is only pointing towards the center of the circle, because for circular motion, there's always acceleration towards the center of the circle. And that is how we know that the child's acceleration will be equal to the centripetal acceleration. Thanks for watching.